Hey everyone, welcome back to Geography 101. This chapter 9, is on water resources. I'm not sure I actually like the placement of this chapter and the sequence of events, but So let's move on. Let's take a quick look at the learning objectives. Here I'm just going to scroll through. You can pause and take a look at these and get a better idea of where we're going for this chapter. So the book talks about to begin with, where the water on Earth comes from outer space and a lot of icy comets at the very early stages of Earth's development. A great deal of the water was trapped inside the Earth for many years, and it outgassed, which continues on today, which is water held in the crust, heated to great temperatures by the internal heat of the Earth, turning it into steam, which has enormous pressure that eventually pops out from the ground. This is a photo from Iceland, and Iceland has done a wonderful job in capturing the enormous stores of energy associated with the steam escaping from the ground, and they've managed to do really amazing things with it in terms of heating houses and generating electricity, etc. So after millions of years of outgassing and outpouring of water from the crustal areas of the Earth onto the surface of the Earth, our planet became pretty much watery. What is it? About 71% of the Earth's surface is covered by water, and the vast majority of that, 97.22% of all of Earth's water, is held in ocean, which leaves not a great deal, somewhere around 3% of fresh water, which is the sort that's not salty, that is drinkable or usable for most of our purposes. What's really very interesting that a lot of people don't recognize is that something on the effect of 78% of that fresh water that's drinkable, usable for irrigation, is actually held in ice and glaciers, which is really pretty enormous. There's smaller percentages. 11% is the most important one, this groundwater that we can actually get to, trace amounts held in the soil itself. So of this water that's on the surface that remains, what's insanely small in my mind, but true, is how much of it is captured in freshwater lakes. That's 0.33%. That's not 33%. 99% of it is in ice and glaciers. Just this last 1% is in all of the lakes and rivers and the atmosphere. It's tiny. And that is really the water that is usable to us most easily. That and this accessible groundwater. So we've got 1% flowing on the surface that we can use, and 11% of fresh water is groundwater. Those are the two that we can really get to easily. This is why climate change is so enormously important, because so much of the glacier meltwater goes into the ocean where it can't really even be used, and among all the other consequences. So keep that in mind. This graphic at the bottom just reminds you that the Pacific Ocean is really pretty big. This is a graphic here, and I'll show you a larger one momentarily, of the hydrologic cycle. And the hydrologic cycle is simply a device to show where the water is moving between its various storage areas on the face of the Earth. What should you remember? Well, let's start with the ocean. The ocean is where the vast majority of the water on Earth is contained, and in order for it to be usable to us, it has to evaporate. So the great deal of evaporation on Earth occurs over the ocean. This graphic you would read, this is 419 cubic kilometers per year of water, and that represents 86% of all water evaporated on the face of the earth comes from the ocean. The remaining 14% of water that finds its way into the atmosphere thanks to evaporation and transpiration, which we'll define momentarily, comes from over land. Unfortunately for us, most of that water that evaporates from the ocean returns to the ocean in storms or snowfall that occurs over the ocean. Some of it, 20%, is blown, these clouds, over land, and of all of the water that comes out of the sky onto the land, onto the face of the earth, 22% of it lands the land surface of the earth, and that is the water that is usable to us. So 78 falls back into the ocean, 22% falls on land. Only about 8% of that water that gets to the ocean eventually goes through either rivers to the ocean or underwater in the groundwater flow back. So this is the hydrologic cycle, and I don't think it's really important that you have all of the exact numbers memorized, but these that I circled, the 86 and the 14, the 78 and the 28 and this 8 here, those are percentages that you should have in mind roughly. So the fact that the large majority of the evaporation that happens on Earth comes from the ocean is something you should know, that the land only contributes about 14% of all of the atmospheric moisture is also important to know, and that about 1/5 of the rain that falls on the planet falls on land surfaces. That seems fair for you to know. Some of the other things maybe you don't have to know as well. So once this precipitation falls on land, what becomes of it? Some of it flows, as you might guess, in streams, lakes, rivers back to the ocean. Some evaporates from the land into the sky, which may be recycled as precipitation back on the ground, but some may go back to the ocean. Plants sweat as well, and water that evaporates from plants is called evapotranspiration. And there is some water that seeps into the ground. Some of it is accessible to plants and returns through transpiration. Some of it escapes plants and through the pull of gravity reaches eventually the groundwater zone and is not accessible generally to plants. So here's evapotranspiration, again explained. That is a compound word, evaporation plus transpiration, and this is all of the water that is captured by the atmosphere from land surfaces as opposed to that which is just plain evaporation over ocean surfaces. Here's a photo of a rain gauge. We have these things on campus. If you're in Geography 102, you'll get to look at these, maybe play around with a bit. The geography department here on campus owns some of these and operates a number of weather stations around Southern California in which we have electronic versions of these.